Angular velocity is defined as the rate of change in angular displacement of an object. It is measured as the ratio between angular displacement over time. So, if a second hand on a clock takes 60 seconds to complete one revolution, what is its angular velocity? We already know time to be 60 seconds, but what is the angular displacement? Well, one revolution around a circle is just 360 degrees, so the angular velocity would be 360 degrees over 60 seconds, which is 6 degrees per second. Since landing on Comet 67P's alien surface, the spacecraft Rosetta and the Philae lander have already collected new and exciting data, but how did Rosetta get to the comet in the first place? Opposed to just traveling in a straight line, the spacecraft made 4 gravity assist maneuvers, or swing-bys, 3 around Earth and 1 around Mars. Gravity assist is the use of a planet's orbit around the Sun and its gravitational pull to alter the path and speed of an object. The spacecraft will accelerate while approaching the planet and decelerate while escaping its gravitational pull at approximately the same rate. So in order to gain acceleration, the spacecraft flies with the movement of the planet's orbit around the Sun, taking a small amount of the planet's orbital energy and thus accelerating. So how can we relate that to angular velocity? Well, we can find the angular velocity of Rosetta as it moves around a planet, let's say Mars. Let's say the arc traveled by Rosetta in relationship to Mars was 120 degrees. It took 8 hours for Rosetta to travel this arc. What is the angular velocity of the spacecraft? Our time is 8 hours, and our angular displacement is 120 degrees, so angular velocity is 120 degrees over 8 hours, which is equal to 15 degrees per hour. We'll leave it as degrees per hour since the most common unit of angular velocity, revolutions per minute, isn't exactly applicable nor convenient to use when discussing aerospace movement.